All right, welcome to Mr. Kingsbury's fun note-taking time. These are going to look a little different. Normally, I would have prepared them in my normal style in the, I can't remember what they're called. But anyway, I would have done it differently, but these notes were just too good to pass up. So actually what we ended up doing in class, and I'm doing this just for anybody who wasn't in class so that you could have them as well. Make sure you title them Characteristics of Cubics Notes, or characteristics of cubic functions notes, if you like. That's fine. Don't forget to put your name. Let's just jump into this bad boy then. So a cubic function is a function with an x to the third power, and it's read x cubed, like so. The parent function is y equals x cubed, and the standard form is, you're going to love this, ax cubed plus bx squared plus cx plus d. And just kind of a general shape of it here kind of looks like this. I'm going to put the points 1, 1, 0, 0, and negative 1, 1 on here. I'm going by 1, so unfortunately I can't put 2, 8 on here. This only goes to 6. 2, 8 would be like up here, and negative 2, negative 8 would be like way down here. But it looks like this. It's like an S. Kind of, sort of. Anyway, and a side note, to get the exponent on the calculator, press the caret key. It looks like this, and then the 3 key. It's above division on the calculator, which I'll get out my calculator and show you how to do some things on it in a second. So we'll go over that, but mostly I wanted you to have that written down. There are several things we're going to do on the calculator that... I think you're going to like. Anyway, so what are the characteristics we're looking for? There are three different types. The first is, is, the intercepts, right? The y-intercept is the point where the graph crosses the y-axis. For a cubic, the y-intercept is written as 0, d. Remember standard form? And there's a d in the standard form? That's the y-intercept. The number d comes from the standard form. Boom. The x-intercept is the point where the graph crosses the x-axis. Very cool. We can find the x-intercepts one of about 3 different ways. You can do it by graphing. Plugging in 0 for y, and then you have to solve it, or from the table, which is awesome. As far as graphing, this is how you would do it. So to get an x-intercept from graphing or from the calculator, first type the equation into y1 and 0 into y2. And I'll show you how to do this in a little bit so that you can get that. A lot of the examples we're going to do, you can pretty much just read them, but I'll show you how to do it anyway, at least on 1 or 2 of them, just so you have that experience. Certainly, if the x-intercept isn't easy to get from the table or read from the graph, this is how you're going to want to do it. And I would avoid plugging in 0 and solving as much as possible, because that's the longest, nastiest, grossest way. So once you plug the equation into y1 and 0 into y2, then you press the following. This is awesome. Press the second button, second, then trace, then, I know what comes up, the second, trace, then option 5, arrow over to the intercept, to the x-intercept. Use the left or the right ones only, not up and down. And then you hit enter 3 times. I'll show you. You guys have found intersections of stuff before. The only difference here is when you put 0 into y2, what you're actually doing is creating a line that mimics the x-axis, and then you're finding the intersection of that line with your equation. Also, important to note, there will always be one y-intercept. And the x-intercepts could go from, there could be as few as 1 and as many as 3. So there will always be one y-intercept and 1 to 3 x-intercepts. And we're going to skip this question right there. Don't be angry, Miss Daughter. Next page. So that's intercepts. Next up, we have something called a relative maximum and relative minimum, or local max, local minimum. I'm going to make that because we're going to probably use both words in class. So I'm going to put underneath here, I'm going to put local. And the reason I like local is because I feel like it helps me to best explain it. To do so, let me just remind you of something called a parabola. Looks like this, right? And you have either a lowest or a highest point, the vertices, excuse me, right? This is a max. This is a minimum. Well, these are actually called global maxes and global minimums, or absolute maximums and absolute minimums, because they are absolutely the lowest or highest point for the entire graph. There are no points higher or lower. That's the way it is. So it's the best in like the world. An relative maximum or minimum, or local maximum or minimum, is the max or the min for that area. So when you have a cubic like this, yes, that is a vertex. Yes, that is a maximum. But if you jump over to this arm, do you see these points on the arm are higher than this? So while it's a maximum in this area, it's not a maximum for the whole graph. Similarly, this is a vertex and a minimum for this area, but it's not a minimum for the whole graph, because look over here, these go down and down and down forever. I like to compare it to like being the best athlete at your school. Maybe you are the best basketball player at your school. Maybe you're even the best athlete or best basketball player in your district. That's awesome. But when you get to the next level, to the collegiate level, you're going to run into people who are better than you. And then if you were to go on to the professional level, you're going to run into even more people who are better than you. You may be really, really good for your high school or your district, but you are not the best in the world. In the case of the parabolas, these are the best in the world. This is like you're the best at high school or your district or your city, maybe even your state, but you're not the best in the nation or the world or the universe. So a little different there. So now let's officially define them. A relative minimum is the lowest point in a specific area. And a relative maximum is the highest point in a specific area. Now we can find these using the graph. Sometimes the points are going to be awesome. Sometimes they're not. Usually they're not, and usually they will be decimals, unfortunately. So, of course, the calculator has a way to find these. I'm going to tell you the buttons, and then when we go to do an example, I'm going to explain a little bit more so that you understand why these buttons work the way that they do and what's going on. So here are the buttons. First, you type the equation into y1. Second, you're going to press second, trace, and then either 3 or 4, depending on whether you want a minimum or maximum, and that'll take you to the graph. Once you're on the graph, then, here's what you do. You select a point on the graph to the left of the vertex. And then you press enter. Then you select a point on the graph to the right of the vertex, and then press enter. My handwriting is getting a little nasty because I'm kind of in a hurry. My apologies for that. And then the last thing you do is you press enter. It's fabulous. I will walk you through that and explain why that works and what's going on. For now, that's all you really need to know. The last little bit here, this is my favorite, is domain and range. The domain and range of a cubic function, it's the same regardless of the function. I don't care what function you're given, the domain and range will be the same every single time. They will always be all real numbers. This will never ever change. And we're going to do all three notations here in a second. The way you write it may be different depending on the form. I don't care. Scribble this off. The copy that I put up on my Google Classroom does not have that sentence, so you don't need to worry about it. If the copy you have does have that sentence, cross it off. Also, the copy that you have should not have it divided up quite like this. It won't have this or this. And there isn't a little piece down here. Yours is updated, so it just says range, and it's this. All right. In fact, this should just be one big thing. So bear with me. All right. And actually, they're both pretty easy. These two are almost identical. So I told you it's all real numbers. Inequality notation, this is what it looks like. Negative infinity is less than x is less than infinity. Interval notation, it's even simpler. You put negative infinity, comma, positive infinity, and you put parentheses around it. So it'll start at negative infinity and end at positive infinity. Set notation looks almost identical to inequality notation. It's just a little more formal. So you put the braces. Oh, and when you talk about set notation, you have to use kind of a nasally voice, like you're real snobby. You say, set notation, okay, so it will be x, such that x is an element of all real numbers, and that's a comma. And negative infinity is less than x is less than positive infinity. Close braces. There we go. So it's a little more formal than the inequality. Honestly, I prefer inequality. That's just me. Interval notation isn't specific enough. As you'll see in a moment, you can't tell the difference between domain and range because there's no x or y. Speaking of which, the range looks identical to the domain. Negative infinity is less than, only this time we're going to use the y. So it's less than y, less than infinity. The interval notation looks identical because there is no x or y, and it's still all real numbers. And the set notation is going to look real similar too. Only this time it's going to be y, such that y is an element of all real numbers, and negative infinity is less than y is less than positive infinity. By the way, this sign means is an element of, and of course this means all real numbers. So with domain and range, you're going to put those every time. And in fact, because they're the same every single time in the notes, we didn't bother with domain and range. We're just going to look at the intercepts and the relative minimums and maximums. So let's just do a few of these real quick. We're going to need our calculator. So example 1 here, we have y equals x cubed plus 4x squared plus x minus 6. Now, before I do anything, if you'll remember, back in the intercepts, I said the y-intercept was always the d value or the constant of the standard form equation. So before I do anything, I can already fill in that the y-intercept is 0, negative 6. And that leaves me with just 3 things to fill in. So here's my calculator. I'm going to turn it on. I'm going to go to y equals, and I'm going to type all this in. Now, I promised I would show you a few things. So here we go. And I'm going to zoom in just a little bit more so you can see what I'm doing. There we go. All right, so I'm going to type in x cubed. My x is right here. That's my x. To do cubed, right over here above the division sign is the caret key. This is it right here. This key. That's the caret key. If you hit that, notice it makes an exponent. And I want my exponent to be 3. Now here's the key. You've got to hit the right arrow to get out of the exponent, or everything else you write will be in the exponent. We don't want that. Then we're going to type plus 4x squared. There's squared plus x minus 6. And if you'll remember, I suggested you put a 0 into y2. So there we go. Now I'm going to hit graph. I want to make sure I can see it. It turns out that really the only thing you need to be able to see are the x-intercepts, which are always going to be on your x-axis. So as long as you can see those, you're good. It turns out the maximums and minimums, you don't have to be able to see them to calculate them, but we'll get there. So it looks like I have 3, 1, 2, 3 x-intercepts, and if I'm guessing, looks like they're at -3, -2, and +1, but let's use the method just to be sure. So second, trace, 5, and I'm going to start over here. I'm going to push the left arrow until I'm close to the intercept closest to the left. And I hit enter 3 times, I get -3, 0. So I write -3, 0. Let's do it again. Second, trace, 5. This time I'm going to arrow over to the other one. Enter, enter, enter. -2, 0. Boom. And then we'll do the last one. Second, trace, 5. Arrow, 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 because that's fun. 1, 2, 3. 1, 0. So that was awesome, and they all turned out really nice. They're nice integer numbers here. Now let's talk about relative minimum or local minimum and local maximum. So I'm going to hit, let's start with relative minimum. I'm going to hit second trace. I want to do minimum, so I'm going to hit 3. This is my minimum right here. I need to pick, see I have a blinky cursor. I need to pick a point to the left of this minimum. So I'm going to use the left arrow. Now here's the deal. If I go too far over here, then I'm going to cause problem myself because I could find something over on this arm that's lower than this. So I'm going to say just to the left of my vertex and hit enter once. Notice an arrow popped up here. If you're using one of the really good calculators, there's also a line that popped up, which I can show you sometime if you want in class or whatever. But ultimately, you've got an arrow, which is great. Then we're going to arrow to the right and pick something to the opposite side. So I'm on the right side of the vertex. I'm going to hit enter. As long as my arrows are facing each other like this, I'm good. So I'm going to hit enter a third time. My minimum is going to be -0.13, -6.06. Please round to 2 places. What did I say? -0.13, -6.06. And now I will do that again, only this time for the maximum. So I'm going to hit second, trace. Maximum is 4. This time my maximum's over here. So I'm going to arrow over until I'm to the left of it and hit enter. And then arrow till I'm past just to the right of it. Not too far, because if I get over here, then I'll mess it up. So I hit enter again, and one more time, and I get that my maximum is at -2.54, 0.87. -2.54, 0.87. Round it to 2 decimal places, please. Sorry, I did not round that right. 0.88. Oops. Whew. That would have been embarrassing. Okay. 3 more, and then we are done. I know this video is running a little long, but I want to make sure you get all of the examples down here, okay? So there's that. Let's do another one quickly. Let's see. So we're going to type this. I'm going to go y equals. Clear that out. So we got x to the 3rd power. Good. And then right arrow to get out of there. Minus x squared minus 25x plus 25. And I hit graph. Don't forget, before we even start, that's my y-intercept, 0, 25. And there's my graph. So we can look at that, and I bet you can see that the x-intercepts are still pretty good. I mean, they haven't gotten into the horrible decimal territory yet. They look like they're pretty nice, but we'll use the calculator to find them anyway. So second, trace, and 5, and I'm going to arrow over to this first one. It looks like to be about -5. I'm going to follow this right here. This is telling me where my cursor's at, and when it gets close to -5, there we go. I'll be able to see it again. Enter, enter, enter. Just needs to be close. Hey, look, -5, 0. That's awesome. Let's see what the next ones are. Second, trace, 5, Now we will arrow to the other side. That looks to be about 1. So I'm going to, when this gets to be close to 1, I'm going to probably hit enter. Let's see what we got here. Where's my blinky cursor? There it is. Enter, enter, enter. Very cool. We got 1, 0. And that's a parenthesis. And last but not least, second trace 5. Arrow over to the last one, which is about 5. I'm looking here. Am I at 5 yet? Pretty close. There's my blinky cursor. Just got to be near it. I got 5, 0. So that was awesome. Now let's try our minimum and our maximum. You can tell from the way things are leaning, right? This is going towards a vertex here, and this is going towards a vertex here. I'm going to hit second trace. I'm going to do the minimum, 3. Let's see. And I'm going to wait till I can see my blinky cursor in here somewhere. That's good. And then we'll arrow back to the right. There it is. Enter, enter. And my minimum is at 3.24, comma, negative 32.49. 3.24. Is that right? 3.24, comma, negative 32.49. That's the minimum. Now let's do the same thing for the maximum. Second trace 4. This time we're going to arrow to the left a whole bunch. I need it to be around negative 5. There we go. There's my blinky cursor. Enter. And then we'll go back to the other side, which is at about 1. Where are you, blinky cursor? There it is. Enter again. Enter a third time. And my maximum is at negative 2.57, comma, 65.67. Negative 2.57, comma, 65.67. Boom. 2 more. 2 more. All right. Scooting up. Scooting on up. Let's type it into y equals, shall we? Negative 2x to the third power. Right arrow, negative x squared plus 13x minus 6. Still got a 0 on y2. That's awesome. I'm not even going to look at the graph yet. The y-intercept is here, 0, comma, negative 6. Now let's look at it. Oh, well, I see 1. I don't see the loops, though, so I'm going to zoom out. Zoom 3. Zoom out until I can see the whole thing. Wow, still not seeing it. Gonna do it again. That is interesting. Not sure why I can't see it, truthfully. Well, let's start over. Zoom 6. I'm gonna start over. Interesting. Well, we'll zoom out. Again, I just wanted to kind of start over to see if that helped at all. We can certainly see 1 there. Let's try it again. I don't know how many times I'll have to zoom out. If this doesn't work, I may show you something else. The problem is when you zoom out, or the more you zoom out, the more compressed the graph gets onto the y-axis, and you stop being able to see it, which kind of stinks. I'm going to try something else. We'll see if this works. I'm going to hit zoom. And if you go down to option 9, it says, I don't know, option 10, it says zoom fit. I guess it's option 0. If you do that, the calculator will adjust its window. Aha! So you can see it. And now what I'm going to do is zoom in ever so slightly and see if that helps at all. And apparently I should have left well enough alone. Wow. Just wow. We'll zoom back out. So you can see there's that. I wish I knew how many times it crossed in here, because I just don't. I can tell you based on the shape, there is no relative minimum or relative maximum. So I'm going to go ahead and put none here and here. The question is, how many x-intercepts are there? And that's a hard one to tell. It looks like it's probably just the 1. But I don't know. It's hard to say. It's really, really, really hard to say. I know we saw the one that was in here. I mean, it could go over and back around like that, maybe. Certainly one way to tell is to go to the table. Anytime there's a sign change, it's crossed the x-axis. But I'm not seeing sign changes here. Let's see, there's 1. And that's it. So I guess it's just the 1. All right, so second trace, 5. And since it's just the 1, I don't have to do anything crazy. Looks like the intersection is 0.46, 0. What I meant by crazy is, since there's just the 1 x-intercept, I don't have to repeat my process 2 or 3 times, and I don't have to get close to anything. There's only 1 intersection. It's on my screen, so the calculator is going to naturally go towards it. When there's more than 1 intersection, you have to get closer to the intersection you're trying to find than any of the other intersections. That was definitely interesting, to say the least. Let's try one more, shall we? So we've got negative 5x to the 3rd power, right arrow, plus 2x. And I'm going to hit zoom 6 just to start over. We may have to fool with the window, though. Okay, that's not too bad. In fact, I'm going to zoom in because it's difficult to see. I think there are 3 x-intercepts. There are 1, 2, and 3. Alrighty. So as always, we look for our constant, our d value for the y-intercept. Please note there is no d value. There's not a quadratic term either. There's no x squared and there's no constant. Well, what number represents nothing? That would be 0. So my y-intercept is 0, 0. And just a word to the wise, anytime the y-intercept is 0, 0, one of your x-intercepts is going to be 0, 0 as well. But you'll see that in a second. Second, trace 5. I'm just going to get close to this one. Enter, enter, enter. And I get negative 0.63, 0. I already have this next one written down, but I'm going to do it anyway. Second, trace 5. And I'm going to arrow over here. Just get close. Enter, enter, enter. It's going to be 0, 0. I already have that written down because remember what I just told you. Second, trace 5. Let's go to the last one, which is right over here. Enter, enter, enter. And we get 0.63, 0. So there are our intercepts. And then the question is, what is our local minimum and our local maximum? So second, trace. We'll do the minimum first, 3. And I'm going to arrow to the right, or to the left rather, of it and hit enter. Then I'll arrow to the right of it and hit enter, and then hit enter one more time. And I get negative 0.37, negative 0.49. Then all that's left to do is find the local maximum. So second, trace, and this time 4. And I'm actually going to arrow just a little bit closer and then hit enter right there, and then go to the other side to the right and hit enter one more time. And I get 0.37 and 0.49. 0.37, 0.49. And guess what? We're done. I know this is a little bit longer video. I'm really sorry about that. I hadn't intended it to be that way. But the notes are intense and in-depth, and there's a bunch to know here. So anyway, we'll practice in class. Hope you're having a great day, and I'll talk to you later. Bye.